Hello everyone. Today in this video I will explain how to apply the variational principle to the ground state of harmonic oscillator to find the energy eigenvalue. Basically, we know that there are 4 steps in variational method. First step is to make a guess of wave function, that is trial wave function. Second step, we have to estimate or we have to calculate the energy by using the trial wave function. Then we have to minimize this energy value by varying the parameters. And the fourth stage is substitute the parameters into the energy value. By applying these 4 steps, we can find the energy eigenvalue as well as the wave function. So let we start how to apply this variational method to the ground state of hydrogen atom. The first thing is that we have to write the we must know the Hamiltonian of this harmonic ground state of harmonic oscillator, that is H is equal to minus H cross square by 2m d square by dx square plus half m omega square x square. This is the Hamiltonian of harmonic oscillator for one dimension. Now the next is we have to guess a trial wave function. In case of harmonic oscillator, trial wave function should be smooth everywhere. It doesn't have any nodes and it should be even function. So we can use a Gaussian function as a trial wave function in case of variational method. So we can use the Gaussian function as a trial wave function. Here psi 0 is a 2 raised to minus ax square, where a is the varying parameters and this is our trial wave function. Now we know that by using psi star psi d tau is equal to 1, by using this normalization condition, we can calculate the value of constant a, and it is a is equal to square root a is equal to 2a by pi raised to 1 by 4. This is the value of this normalization constant. So finally we can use this. So now this is the first stage, that we guess a trial wave function. Then in the next stage, second stage, we have to take the expectation value of H, that is the energy eigenvalue, and should be written as expectation of H is psi 0 H, and here is psi 0. Then again we can write it as integration of minus infinity to plus infinity. This is psi 0 a power minus ax square into this is h is minus h cross square by twice m d2 by dx square plus half m omega square x square into sin, that is a raised to minus ax square and dx. So this is the expectation value of h, that is the gives us the energy eigenvalue. Now we can solve it as this is a is constant, then we take a square outside and integration of e raised to minus ax square. We have to multiply this and plus this into this. So first we take this term a power minus ax square into half m omega square x square into e power minus ax square. So this e power minus x square becomes e power minus 2ax square, and here we can write dx plus, now this term I will write here, integration of e raised to minus ax square into minus h cross square by twice m and d by dx. First in differentiation of this e raised to minus ax square will be minus 2ax e raised to minus ax square, okay, complete, into dx. So I hope you understand this step. Here we taken first differentiation, and again there is another differentiation with respect to x. We will solve it in the next step. So the second next step, a square as it is. Here m omega is constant, so we can write half m omega square outside and integration of e raised, sorry, here x square is there, x square e raised to minus ax square dx. Plus here we can write this term out of this yes, minus h cross square by 2m, and in the integration e raised to minus ax square, and here again we take the differentiation, it becomes minus into minus plus 4a square x square, that is 4a square x square, and again e raised to minus ax square plus minus 2a power minus ax square dx. So here there is, we have to use u differentiation of u into v, differentiation of u v plus differentiation of v into u. Okay, I think you understand this term. Okay, now another thing, we know that the integration in this form x raised to 2n e raised to minus ax square dx, it has a special formula, integration formula, and we have to apply that formula here in this case. So first I will write the formula here, that is integration of x raised to 2n e raised to minus ax square dx. What is its answer? Directly is equal to square root of pi divided by 2 raised to n a raised to n into square root of a, and here 1 into 3 into dot 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 2n plus 1. This is the standard formula for this integration. I am going to use that formula here. So first I will, here we apply this formula to this equation. First thing, a square as it is, and here m omega square by 2. Now here we can see x square e raised to minus 2ax square dx, and our formula is x raised to 2n e raised to minus ax. So the value of n in our equation is 1 and value of a in our equation is 2a. Hence we can write directly square root of pi divided by 2 raised to n, that is 2 raised to 1, into a raised to n, that is a is 2a, so it is 2a into square root of 2e. Okay, now plus, here there is a minus, so directly we can write minus h cross square by 2m. The first term e square e raised to minus ax square into this. So directly we can take the constant outside for h cross square. This a is constant, a square, and inside the integration x square e raised to minus, this is e raised to minus ax square, e raised to minus ax square, it is 2ax square, and dx. Now this minus and this minus will become plus, and here this 2a is constant, minus h cross square as it is divided by 2m, and here again e raised to minus ax square, e raised to minus ax square becomes e raised to minus 2ax square dx. Okay, I think you understand this step. Now in the next step we can write again a square m omega square square root of pi divided by 2 into 2 4 into 2 8a and square root of 2a, this minus 2 cancels, so 2h cross square a square by m. Now here again we have to use this formula x square e raised to minus 2 ax dx, and if we apply this formula here, again we get square root of pi divided by 2 into 2a square root of 2a plus this 2 will cancel, then a h cross square by m, and here the power of x is here the n will become 0, so this we can use this formula as directly we can write square root of pi divided by a will become 2a square root of 2a. Okay, first thing we have to use this formula very carefully, then we will get the correct answer. Then we know that a is a normalization constant, and this value of normalization constant we already discussed in the beginning, that the value of a is 2a by pi whole raised to 1 by 4. Hence the value of a square I can write here directly square root of 2a by pi, and here again we will write here m omega square square root of pi divided by 8a square root of 2a minus this 2 will get cancelled, then we will write here h cross square a square root pi divided by this 2m, a will cancel, square root of 2a, and plus again we have to write here h cross square a by m into this square root of pi upon 2a. Okay, now we have to multiply to this by 2a by pi. Therefore this 2a by pi by 2a, root pi by 2a, and square root of pi by 2a will get cancelled, and the remaining terms are m omega square divided by 8a minus here h cross square by 2m plus h cross square a by m. Now this is h cross square a by 2m, h cross square a by m. From this we can write m omega square by 8a plus, if we calculate this, we will get h cross square a by 2m. So this is the expectation of h, and this expectation of Hamiltonian is with respect to the trial kit or trial wave function, and hence this is the energy eigenvalue with respect to the trial wave function. That is, by using trial wave function we have estimate this ground state energy of that ground state of harmonic oscillator. Now if we plot energy versus A, that is a varying parameter, this A is used here as a varying parameter. So if we plot a curve A versus energy, then we will get this type of graph. If at x-axis there is A and at y-axis there is EA, that is the energy with A, then we will get this type of curve, and in this curve the minimum value of E, if we say that is E0, then it corresponds to a certain value of A, that if I say A0, then this value of A0 can be obtained with the minimizing this value of E, that is at this point, that is at minimum energy, we will get A0, and by this relation, if we get the value of A0, then we can substitute the value of A0 into our equation. So how we'll get this? For that, we must know for the A0 we have to use the minimization for this E. So that we understood that the minimization of E0, that means at this point energy will become constant for this dA. For this space energy will becomes constant, so we can write dou E by of A by dou A is equal to 0. If we apply this condition to this E, we will get directly the value of A0. So we know that E0, this is our E0, and E0 by A. Here m omega square by 8A will becomes m omega square by minus m omega square by 8A square, and this term will becomes plus h cross square by 2m. And if we assume this is equal to 0, or we equate this equal to 0, then we get m omega square by 8A square is equal to h cross square by 2m, and from this here we have to calculate the value of A. For that I will transfer this 1 upon A square is equal to 8A square h cross square by 2m square omega square, and from this we can write A is equal to, this will cancel, A is equal to m omega divided by 2 h cross. The value of A will becomes m omega by 2h cross, that is A0. So this is the value of A0 where we apply a condition dou E0 by dou A is equal to 0. Hence this is the value of A0 at energy is minimum. So we can say it is a ground state energy. Then if we substitute the value of A into our equation, in this equation we will get the directly ground. Now finally we can substitute the value of A0 into this E equation, which is the fourth and final step of the variational method. That we substitute A0, then EA0. When we substitute this E0, we will get the energy at A0, that is the minimum energy in case of ground state of harmonic oscillator. So let me see what is the ground minimum energy in case of ground state of harmonic oscillator. So here we have m omega square by 8 into 1 upon A, that is 2h cross by m omega plus h cross square by 2m into A is m omega by 2 becomes 4 h cross. So if we cancel this omega with this, there is 2 becomes 4. So finally we can write here m will cancel, so h cross by 4, and here one term is that omega, and plus here also this h square will cancel, m will cancel. So finally the remaining terms h cross omega by 4, and if we add these two we get half h cross omega. What is this? This is energy at A0. So from this what we can observe, energy at A0, that means the minimum energy in case of ground state of harmonic oscillator is half h cross omega. So we can prove by using this variational method. Okay, so this is our required answer. Now also we can extend this to find the wave function. Wave function, we have a trial wave function, that is a raised to minus ax square. Now if we substitute the value of a, value of here small a, then we will get the wave function for ground state of harmonic oscillator. So if we substitute the value of a and capital E, you know the value of capital E is 2a by pi raised to 1 by 4. And what is this value of small a here? So becomes 2 by pi into this m omega by 2h cross. So this will cancel h cross. So the remaining terms are m omega by pi h cross into this e raised to minus m omega x square by 2h cross. So this is the wave function for ground state of harmonic oscillator.